Okay, so we're going to be working on page 16 problems, but I'm actually starting by going over the problem-solving method that I'm going to be using to analyze these problems. There's not really a lot for you to be writing down here at the bottom of page 15, but please follow along at the very least. So this problem-solving method is called the GUESS method, and each of those letters stands for one of the steps in our process. And the first step is our given. That's what we got to work with in the problem. So you start by looking for what you have, and then you want to look for where you're going with that. What are we trying to turn it into? What is the question asking for? And actually both of these things are going to be part of the question in your problem. So my recommendation when you get a problem, especially a big long word problem like some of the ones we're going to be solving, is look for the question. And that's going to be where you find your key information. That might seem counterintuitive that the given information is in the question, but if you think about it, I might ask you something like, how many oranges can I trade for 5 apples? Well, the question is, how many oranges can I get? But the given information there is that I have 5 apples. So find that question. It should have all the information for you to start your problem with. Any other information is probably part of an equation. Sometimes in certain problems that aren't dimensional analysis, you might have an equation, like that percent error equation that we learned about last class, that you could put here. But most of the times with really straightforward equations like that, you don't need to follow through all of the steps of this process. But dimensional analysis, we're going to be putting our unit equations here. And I'll talk about what a unit equation is, but they're really short, simple facts that you know that are going to help you solve the problem. Now, these last 2 S steps are the required steps. Everything else you don't have to do. But I need to see you set up and substitute in those numbers that we're going to be using in a way that's going to solve the problem. I don't need to see every single step along the way, as long as I see this setup here with all of them plugged in where they're going to be going. So this is where we're going to do the dimensional analysis setup for our process, and that is required. And then, of course, the solution should be boxed, should have units, it should be rounded correctly. If you don't have all of those things, you won't be getting full points for that answer. Now, it is a good idea in general to think about the answer you get of, does it make sense that I would get 10 apples for these oranges? Or should I get more or less? But in general, some of our chemistry problems, it's going to be hard for you to rationalize one way or the other. So it's a good idea, especially as we're starting, because a lot of these problems we're going to work out here at the beginning, you might be able to solve another way. You might be able to think about it, and some of these processes are simple enough for you to get another way. But please remember, our focus right now is for you to understand the process of dimensional analysis. We're going to use this to solve much more complicated problems down the road, but we're giving you the problems we've got now to make it a little bit more manageable and relatable. So if you can solve this problem another way, that's a great way to check your answer, but you are not going to get any credit for any of these problems unless you use dimensional analysis to solve it. So before we get actually looking at these problems, I want to kind of give you a little bit of information that you might not have already. On Canvas, I've already posted the answers to all of the calculations for the rest of the packet. If you go to our current module and scroll down to the bottom, or I guess I'm not sure exactly where you're at right now, but as of this recording, we have this set up here, and this is our really important notes that you're going over, and right underneath it is our Unit 1 packet calculation answers. Now, as the post-it note says, these answers earn you no credit without showing the dimensional analysis work, but at least here you can check your work as you're going through it. So I'm going to be working through most of the problems on this page, but if you get the process and you want to just put me on pause and try the next one, then you can come back to this place on Canvas. This is still there, always will be there, for you to check your answers. And if you're getting my answers, there's no reason you should have to sit and listen to the rest of this video. If your answers aren't matching, or you're not sure where I rounded it where I did, then you can then continue playing the video. But I've got everything in here all the way through the end of our packet so that you can kind of be self-paced and working. That's basically what we're going to be doing to finish out this unit, is practicing what we're learning here in these videos and just doing a little bit more of that. So that is a resource that's there for you. And so now let's actually get to the top of page 16 where we need to fill some stuff in. So this is, once again, nothing to write quite yet, but most of the problems we are going to be solving in class is going to be unit conversion problems, where it's like the apples and oranges problem. It doesn't sound like unit conversions, but I've got apples, I want oranges, and those are units to us. And so dimensional analysis is a way of solving problems that's entirely unit-based. There are going to be numbers in here. It is a calculation, but we're honestly going to ignore the numbers for the most part and use the units to set everything up. And then at the end, we're going to go back and pay attention to the numbers again. So this is where we really need to start some writing. Your page has a place for you to write the definition of a conversion factor. And that is a fractional form of a unit equation. That sounds pretty simple, but I want to make sure you know what a unit equation is. And because those are what's going to go in that equation section of our guess method. And all a unit equation is an equation, so it has an equal sign in it, with two equivalent quantities that have different units. So just saying something like 1 inch equals 2.54 centimeters. That's an equation, because they're equal to each other. It's just a simple fact that we know that's going to help us convert between those units. So when we turn that equation into a conversion factor, we just make it into a fraction by putting one side of the equation on top of the other. And it doesn't matter which one is on top yet. We can use it either way. The way we decide how to change and set up that unit equation is going to be based off of our problem. And before we get to that next slide where you're kind of answering that, think about it. If we had a term like 3x over 4 in a math class, and I was trying to use some kind of conversion factor to cancel out parts of that. If I was trying to cancel out this 3, then I would put the 3 on the bottom of my conversion factor, because then I'd be doing 3 divided by 3, even though these two separate conversion factors are being multiplied together. And here, if the 4 is on bottom, to cancel it out, I'd put the 4 on top. For those of you who recognize this, this is the reciprocal method of solving some kind of fraction problems, and I'll stop pretending to be a math teacher now. But that's all that we're really doing here with our conversion factors, is making sure things line up on the opposite side in our conversion factor. It's the last thing for you to write down. The opposite side is how we cancel things out. So, and most of the time, the opposite side's going to be the bottom, because we start with our numbers on top of our big, long dimensional analysis kind of fraction line. So, I want you to watch one problem happen. No, that doesn't matter. I'm going to solve this problem, and you don't have to write this down anywhere. In fact, I don't want you to write it down, because I want you to focus on what you're seeing happen here. Now, in class, I was asking people to interrupt me so that they could make sure of what they're doing before they actually have to do it, but just watch and let me know if you have any questions. So I'm going to go through this guess method with you, and it starts by finding our given and our unknown. So my question is, how many M&Ms could you burn off by running a marathon? So my given here is that I'm running a marathon. So my given is this 26 miles. And what I want to know is how many M&Ms I could eat after that marathon. How many M&Ms I would have been burning off during that marathon. So I'm trying to connect and convert miles into M&Ms. And that might not be something that you can just do in your head, or maybe you can figure it out. It does continue giving me some information here that I should assume an average person burns 310 calories for every 3 miles. So that's actually my very first equation that I'm going to use here, is that 310 calories will equal 3 miles. And then I need to I'm kind of thinking about connecting these two things. So I've gotten my miles connected to calories, but I don't have my calories connected to how many M&Ms I could be eating. And so in order to kind of finish this connection, I'm going to have to look at my label for my M&Ms. This tells me that 32 pieces have 140 calories. So I can make that into another conversion, another unit equation. 32 M&Ms equals 140 calories. So these are my two equations. Just put in parentheses to kind of keep them separate there. And this should get me to my answer. So I'm going to switch colors here. And one of the most important things to remember when you're starting your dimensional analysis is that we start with the given. So this number, the first number that we found and emphasized, is going to be the first number as we set up our dimensional analysis. So I generally write that number out. 26 miles needs the units. The units are everything to us right now. And so then I draw the line, because this is going to be one big fraction. And I like to draw my line and then break it up, add those conversion factors one by one, and then I can erase as needed. But some people prefer to just draw this line here, and then they add a single conversion factor, and if they need to add more, they can add more space because they don't like erasing. For some reason, it bothers me that that line isn't perfectly straight, so I always start with one big long straight line, and then, like I said, I work backwards or not backwards. I will erase it at the end if I didn't need that full line. It's up to you how you set it up, but we're going to be using these vertical lines to kind of break up this space between that given and the conversion factors, which are coming from my equations. So what I need to do here is pay attention to the units that I have on top, because I don't want miles. I want to cancel out miles and eventually get to M&Ms. And the way I'm going to cancel out those miles is by putting miles on the bottom of this next bracket, the bottom of this first conversion factor that I'm using. And as I'm looking at my equations, the only equation that has miles in it is this first one. So that's actually going to be 3 miles down there on the bottom, and that other half of my conversion factor just goes on top. They have to stay together. They just end up putting one part on bottom, the other part on top. So this has essentially canceled out my miles because they're the same on top and bottom. They go away. The numbers are still here. Don't cross out numbers. And in fact, you don't have to cross out those units, but just check and make sure that the units we started with are gone. Now what I've got is calories. So technically, if I stopped and calculated here, this would tell me how many calories I burn off in my marathon. But that's not what I'm wanting. I want M&Ms. So I'm going to have to keep going. We already used this equation. So this is probably going to be the equation I end up using, because that is going to help me get rid of these calories and get my M&Ms. But remember, to get rid of the calories that I've got on top here, I have to put calories on the bottom of this next bracket, on the bottom of this conversion factor. And I'm actually going to scooch that over because I don't need that much space here. So this 140 calories is going on the bottom. That means that those 32 M&Ms can go on top. I can cancel out those calories if I need to visually see those units going away. So now I'm left with M&Ms, and that's what my unknown was. So as soon as I have my unknown units up on top of my dimensional analysis, then that means that I am ready to stop setting it up and actually solve for my answer. So I'm going to erase this little bit more that I have here and explain that in order to solve this problem, what we do is take all these numbers that are still here. We've canceled out a fair number of units, but all of these numbers are still here. And we're going to multiply all of the numbers that are on the top together and divide by all of the numbers that are on the bottom. There are a couple other ways you could plug this into your calculator, but a lot of them will result in more errors and more mistakes. And this is the best way I've found to do this and to teach this. And I do literally mean to plug all these numbers in all together. So you're going to do 26 times 310 times 132. Keep going and divide by the 3. I'm going to get rid of that arrow. Okay, I had needed more space to write that out and make it more clear, and I'm sure that I said something wrong there. So what I'm doing here is doing all of this all at once. At the very end is when I will push the equal sign. Every single one of these numbers goes in at once, and you're going to make less mistakes, because now when we get our answer out to be 614, I mean, I kind of figured that might be a little bit bigger, like 6,000-ish, but at least it's not like 6. So I'm pretty sure that this number is correct. And just make sure that that number gets units on it. And that's good. That's all that we need. So if you're not getting 614, or I told you not to actually do this calculation with me, if you're not getting the answer that I'm getting, it's probably because you're not plugging those numbers in the way that I am. So it's really important that you do the calculations that we're going to be doing on the rest of this page together. I know that it might make sense to just write down my answers. They're all right, great. But if the first time you're pushing the buttons on your calculator and trying to make your setup, your dimensional analysis, turn into the right answer on a test or a quiz, then you're not going to have a good time. So you need to try it. And if it's not working out, don't be embarrassed. Come and ask me, because there's probably something simple that I can help you with, and it'll fix everything. So let's get started with an actual example. 17 minutes into your podcast. I know it seems like a lot of time, but we spent a lot of time on this in class. So this is the first problem that's actually in your packet, and hopefully we can go through this a little bit more easily, and it makes a little more sense why we're doing what we're doing. So here, this says, before the use of money, people bartered for goods they needed. If 25 chickens could be traded for a pig, 10 pigs could be traded for a cow, and 2 cows traded for 3 horses, how many horses could be exchanged for 1,500 chickens? So, zeroing in on our question here, how many horses could be exchanged for 1,500 chickens? My given is those 1,500 chickens. That's what I've got. And what I want to know, what is my unknown, is how many horses I could get for those chickens. So all the rest of the stuff that was in here are equations. So it's telling me 25 chickens can be traded for 1 pig. So that means 25 chickens equals 1 pig. Now I see that 10 pigs can be traded for 1 cow. So that's our second equation here. 10 pigs equals 1 cow. And then 2 cows can be traded for 3 horses. That works, right? So we've got these 3 equations here. I don't see any other numbers in need of being written down. So it's time to get started with that dimensional analysis. What I want to reinforce is that there's a lot of numbers going on here, but the numbers that we use, so the number we use to start this process is always our given. So I'm going to write those 1,500 chickens, whatever we've got, and I'm actually going to shorten that down, keep that as just chicks. So that's what I've got. Those are the units that are on top, but I know I don't want those units. I want to get rid of them and try and get to horses. So I'm looking through all my equations, and this is the one that has chickens in it, the only one that has chickens in it. So I'm going to take those chickens and put them on the bottom of this conversion factor. And if that 25 chickens went on the bottom, then that 1 pig, the other half of that conversion factor, has to fill in the top. And now we're done using that equation. And we have so far gotten rid of chickens. And if I stop and solve now, I'll get pigs. I don't want pigs though, so we gotta keep going. We're not done yet. And my goal in this next conversion factor is get rid of pigs. I want horses, not pigs. And as I'm looking around, I don't have anything that can get me directly there. But this next equation will get me a little bit closer because it has pigs. I can put those 10 pigs on the bottom to cancel out with the pig that I have on top. Just remember to keep that whole equation together. If 10 pigs is on the bottom, that 1 cow is on the top. So now we've used another equation as a conversion factor, and now that's converted the chickens into pigs and now into cows, but we don't have what we want. We're going to keep going until we have horses. But luckily for me, it looks like we can get horses with this last equation because that has cows, so that I can cancel out these cows, and then it has horses that are going to end up on top. So my cows are now canceled out and gone. What I've got left is horses and a whole bunch of numbers that I need to put together. So I am done. As soon as I've got my unknown unit horses in my setup, then I stop and calculate. And remember that we're going to calculate by multiplying across the top. You don't have to actually write these in. I just do this to kind of remind you of what you're doing, and maybe these first few times it's a good idea to write it in to remind yourself how to do this. But I would recommend all together in your calculator all at once. Do 1,500 times 1 times 1. Although you probably don't need to actually do those times 1 parts because multiplying and dividing by 1 doesn't change the answer. We still need to account for them in our dimensional analysis. Dividing by 10 and then dividing by 2. There we go. So this is our whole thing all together, and other than maybe not actually pushing these buttons to multiply by 1, let alone twice, we need to put all these numbers in together. And if we do that, then surprisingly enough, our answer turns out to be 9. So I can trade all those chickens for 9 horses, evidently. And I am missing that unit, horses. Even though it's not a chemistry unit and it doesn't seem quite as important, it is. Every single answer gets a unit. And then there's one other thing I have to touch on, because this still isn't a perfect answer, because we have to make sure that this answer has the same number of significant figures as our given. None of the rest of these numbers matter for significant figures. The only thing that matters is our given. So in here, my 1,500 has 2 sig figs. The 1 and the 5 are the only significant digits. Those zeros are not significant because there's no decimal anywhere in that number. So if this had 2 significant figures to start the problem, I need to end the problem with 2 significant figures as well. And without changing 9 to another number, I can just add that 0.0 to make it exactly 9 horses is what I deserve for those chickens. And that's our answer. And you'll see that exact same answer on our answer list. So, pretty happy with that. And moving on to the next problem. Okay, so on this second problem, it says that we've developed a system for placing values on cars. 1 Maserati is worth 3.5 Porsches, a Porsche is 5 Jeep Wranglers, 2 Jeep Wranglers are worth 15 Ford Pintos. If I collect 225 Ford Pintos, how many Maseratis would they be worth? Okay then, so here we have our question. If I collect 225 Ford Pintos, how many Maseratis would they be worth? So my given is those Ford Pintos. That's what I've got, and I want to figure out how many Maseratis I can turn those into. Now, the rest of this are equations, so I'm going to start writing those out. And this is my first one, and I've decided I'm definitely going to abbreviate these names because they're so long I would never have enough space. So that's my first equation, and then here's my second one. Okay, and then 2 Jeep Wranglers are worth 15 Ford Pintos. Okay, now I'm not going to set the entire process up for you this time. I've given you everything that you need to do this yourself. And I am going to get you started because a lot of people forget how to get started with this process. What you need to remember is we start with our given. So that's 225 Ford Pintos here. So that's going to be our given. Move on to using these conversions to cancel out those Ford Pintos and everything else along the way until you get to those Maseratis, until we get MAS for Maserati up on top. Then you're done, and according to our answer key, we should be getting 1.71 Maseratis out as our answer. But I am going to be checking this question to see how you set it up and if it's correct or not. If you're not sure how to set this one up at this point, you need to come and ask me for some help, or maybe watch a couple more examples and try and follow along with that process. But if you're getting stuck, I understand it's a confusing process, so come and ask me for help. If I can watch you do it, I can generally figure out where you're going wrong. It's just extra hard to do this virtually. So, moving on to the next problem. This problem is a little bit more of a chemistry problem, and it's not really a question. It just tells us to convert 500 grams to ounces. So that is my given here, and ounces is my unknown. And then it goes ahead and it gives me my equation, so I'm just going to transfer those down here. And now I'm ready to get started on my dimensional analysis. Remember, we start with our given, which here is 500 grams. I need to cancel out those grams, so I'm looking in my equations and finding the one place that has grams and putting it on the bottom. The other half of its equation, that 1 pound part, goes on top. I didn't quite get to ounces, so I'm going to need another conversion factor. Cancel out those pounds, and so that's actually going to be the same, but it's not the same here. I've already used this. It looks the same just because it has that same constant on this side of this equation. So now I'm putting this pound down here. That means that my 16 ounces can go on top. You don't have to cross everything out along the way and circle stuff if it gets too messy for you. All you need to make sure while you're looking over things before you calculate is double check that you started with your given, good, then that we have our cancelable units on these diagonals, top here, bottom there, good. Top, bottom, I'm left with ounces, which is what I was looking for. So you can find all of that information and check whether your setup is good without having to make it all messy. So I'm confident in this setup, and when I multiply it all together, then that is going to get me 17.62. And I know I just said multiply it all together, but I am still multiplying the top and dividing by the 454 and the 1 on the bottom. And I know that the numbers keep going, but this is the basics that I need. And then I need to look back at my given, and this actually only has one significant figure. So I need to round this answer to just have one significant figure. So I'm rounding this answer to the nearest tens place, and that's actually going to round up to 20. So that's why you see that answer on my answer sheet as 20 ounces. It really did come out to 17.62, but because I'm not 100% sure that's exactly 500 grams without those zeros being significant, this is like, I got about 500 grams. All we can be sure is that we'll end up with about 20 ounces here. So that significant figures coming into play and giving us a little bit more meaning to these numbers. In this next problem, it's asking us how many grams are in 2.33 moles of water. Now, we talked about moles a little bit. We still haven't really studied them super well, but we don't have to know much about them in order to be able to solve this problem. I can tell that that is my given, and I want to find grams. That's my unknown. And then it gives me my equation right here. I'm not even rewriting it because it's just sitting right there begging to be used. So when we start this process, my given, those 2.33 moles, and mole can be abbreviated down to MOL if you'd like. That is the official abbreviation. I'm not making it up. And then we just need this one equation. That 1 mole goes on bottom, 18.02 grams on top, and in one step we've canceled out moles and we've got the grams that we needed. So we're ready to calculate and get this answer out. And my calculator was telling me that that was 41.9866 there, but just writing down those first few numbers to look at, I want to know how many to round my answer to, so I'm looking back at my given. This had 3 sig figs, so I only really want to keep these 3 sig figs, but that 8 is going to round the 9 up, which is then going to round that 1 up, so my answer is 42. But I need to make sure, once again, it has those 3 sig figs, so don't forget that 0.0 there, and of course, don't forget our units, our grams. So those last few problems have added a little bit more realistic chemistry units into things, and then this one makes it even more realistic because all it is asking a question and giving you a given. It doesn't physically give you all the equations you need in that problem. And that's why our chemistry problems can seem so crazy and complicated, because it doesn't give you everything you need there. But you should be able to write out some unit equations that can help us connect these values. So just framing that question, evidently I've got 24 hours and I'm trying to figure out how many seconds there are in that. And so I need to come up with some equations, and you should know some basic things about time that can let you write some unit equations here. So if I want to get to seconds, what I know about seconds is that in 1 minute there are 60 seconds. But what do I know about hours that are going to get me closer to seconds? Well, 1 hour is 60 minutes. So I'm kind of connecting the dots here. Both of these different things are connecting to each other through minutes. Even though it didn't ask me for minutes, I kind of have to go through them to get to my answer. Sorry about that. So many bells today. And we're just going to start off with our given here, 24 hours. And then starting to use that last equation that we just came up with. 1 hour has 60 minutes. And then in 1 minute, there are 60 seconds. So it's not that bad. 2 conversions will get you there. And then, of course, we're multiplying and dividing. I'm showing my work there, although once again you're probably not going to divide by 1 twice, or you don't have to push those buttons in the calculator because it won't change things, but feel free to make sure to push all the buttons. And honestly, this is probably what you would have done in your head when I asked you this question, is, oh, I know that there's 60 of these and 60 of those, so you probably could have done this all on your own, which is one of those times when I told you, you can solve these. I know I've got smart kids, but learning how to set up this with dimensional analysis and learning why and how that brain process that you're going through gets you that answer can help reinforce this process. So this is what my calculator is telling me, but don't forget to check your given. That just has 2 sig figs, so I'm only going to keep these 2 answers, and that 4 does not round my 6 up. So my final answer that you would have seen on our page of answers is going to be 8,600 seconds. Okay, now these last 2 problems on this page have a little bit of a twist to each of them. So not too much to begin with, and this problem really doesn't have much to it. We're trying to get our given, which is in inches squared, to turn into our unknown, which is feet squared. And if I'm thinking about an equation that I know myself about inches and feet, then 12 inches is equal to 1 foot. The only problem with that is, while I do know that and I can count on that, that's not quite the same units as what I'm seeing in my given and my unknown. Those units are squared inches and squared feet, and this is not the same. Normal inches and normal feet isn't the same deal. We can't use it like that. We have to square these units in order to be able to cancel out the squared units that we're starting with. But that's not all that we need to do. We can't just square the units. If we have an equation and we want to square the units, we also have to square these values that go with them. Now, 1 squared is just 1, so we can leave that alone. But 12 squared is 144. So we're going to go ahead and change this to say 144 square inches is equal to 1 square foot. And if you think about it, a square, that's 1 foot by 1 foot, T didn't show up, would be 12 inches by 12 inches, and 12 by 12 would make 144. But you don't have to think that hard about these things if you just take a simple equation and it's supposed to be squared in your given or your unknown. Just take that unit equation and square everything. Whatever you do to the units, just do the same to the numbers. Same goes for cubing them. That is still technically the same equation. We can just alter the way it looks a little bit. And now that we have that equation ready and I've explained it enough, this process is simple enough. If I take that 1650 inches squared, then I need to have my inches squared for my equation on the bottom and 1 foot squared on top. And then this ends up coming out to 11.458 and some more numbers in there. But looking back at my given, this had 3 sig figs, so I'm really only trying to keep these first 3 sig figs. So my correct answer, correctly rounded, is 11.5 square feet. Simple conversion, you just need to make sure you know how to alter that equation. Now, our next problem, if I will open it up, why is it not moving? It appears like my screen is frozen. Give me just a second. Okay, there we go. This problem, the real kind of twist is how it gives you your given. So we're trying to find miles per gallon, and what we're starting with is kilometers per liter of gasoline. So this is just the efficiency of our car. But I'm actually going to rewrite our given here is 10 kilometers per liter. Normally when we write these things out, and you might see that as well in your car when you see miles per gallon written out someplace in your fuel efficiency, maybe if you have a newer car, you use that slash to represent per. So what we're trying to get our final unknown units to be is miles/gallons. And what we're starting with is kilometers/liters. And that really is almost a fraction with kilometers over liters here. And so one way or the other, however you write this out, when we're starting this problem, the main thing, and we have all the equations we need right here in that problem, is when we're starting this dimensional analysis with this problem specifically, with these combined units that we've got here, the key is to make sure that this line goes through our units, just like this line over here went through our units. So we have to start with liters on the bottom. There's no number there. The number is here with the kilometers. It's 10 kilometers per liter. We just need to make sure to break up our units the way that they're technically breaking them up in that problem. It just doesn't look quite the same. But now we have 2 units to start with, and we want completely different units. We want to change each of these to some different newer units when we get to the end for our unknown. We want miles on top and gallons on bottom. And so even though we are starting with these combined units here, we are going to pay attention to them individually. We're going to change those kilometers into miles Then we're going to change those liters into gallons, and then we'll be done. It just feels a little bit weird to be ignoring some of the stuff that we've got here. So for right now, we're focused on these kilometers, because this is going to be the same process that we've always followed. We've got a nice equation here that tells me that 1.61 kilometers goes on bottom to cancel out the kilometers that we had on top. And then 1 mile goes on top. So our kilometers are gone, and what I've got here is miles. And that's what I want on top by the end in my unknown. So now we're done with this part. Our kilometers are gone. And now I'm going to move on to trying to cancel out the liters and get gallons. And I'm just going to leave miles here. I'm not trying to cancel it out or do anything with it. I'm done with it, and it's staying right there. So I'm now completely focused on these liters. And I want to use this equation to cancel out the liters that I have and get gallons. And this is where things are a little bit weird, again, is because to cancel out these liters that are on the bottom, I'm going to have to put my liters on the top of this next bracket, on top of this conversion factor. So that 3.77 liters is going on top, and 1 gallon is going on bottom. So now we've used all our equations, double checking our diagonals. I wanted to cancel my liters, and here we go. Those are canceling. Opposite sides, liters on top and bottom, no matter where they started. Once we have 1 on each side, they cancel. And so now I've got miles over gallons. That's all that I really wanted. And honestly, if you were looking at this and you started by changing your liters into gallons, that's perfect. That's fine. It doesn't honestly matter which of these steps goes first in this situation, because they are completely separate steps. So now that means that it is time for us to multiply and divide in order to find our final answer. And just reminding you, this is how we set this up in our calculator. I really encourage you to do all of these calcs all together, all at once. And that tells us our answer is 23.41614907. But looking back at our given, this 10, and I was being lazy when I wrote that down. I saw 10, and I'd rewritten it over here. But the number I was given here had 3 significant figures, and so I really should have kept those numbers because they were important. So if that was 3 significant figures, that means I just want to keep these 3 significant figures. So I'm actually going to just erase the last couple numbers because I'm running out of space to rewrite things. So I've got 3 significant figures and my units, miles per gallon. And now this is full, complete answer. So that's the last question that we really have on this page that we were going through in class together. There are some other practice problems that we'll kind of go over as we move on, but that's what you kind of missed in class. So at this point, the next page of your packet is the metric prefix conversions. And some classes got to start on going over this with me and some did not. But you actually should go ahead and jump to your podcast that was a homework this night, because on that podcast on page 17, or rather, it starts on page 18. At the end of the podcast that I posted, I have notes for classes that didn't completely get to these notes on page 17. So if you did miss class, then you missed these notes as well, and you can get them in that podcast. So there's kind of a 10-minute podcast going over page 18 and some density stuff, then some page 17 notes at the end of that in case you missed that. So at this point, you should be able to catch up with us in class and join us for practicing some of this dimensional analysis stuff, because it's an important skill and we're going to use it all the way through this year.